Our next presenter is Mark Llewellyn, is Manager of Spectrum Advocacy at Deere & Company. His responsibilities include regulatory, technical, legal, government affairs, and public relations issues concerning electromagnetic spectrum. Of particular interest are global navigation satellite systems, mobile satellite systems, rural broadband, interference protection standards for receivers, spectrum allocation policies, wireless data communication systems, and telecoms. That all sounds very technical. As a farmer, I will say that we use GPS in our combines and tractors, so I know what it looks like from the ground, but I don't understand everything else he does. So welcome.
Good morning. My name is Mark, and guess what? I can't wait to show you my maps. All right, so my topic is infrastructure gaps in the United States. So I want to give you a little bit of a perspective here and what our problem statement is. We heard our first speaker, Ann, talk from a 10,000-foot perspective. Well, I'm from John Deere, so we dig dirt. So we're going to talk about it from on the ground, okay? So we've heard also from our earlier, from Sharon, about the rural broadband gap. So I don't need to talk about that. We've already had it documented. We all know about it. But we may not realize is how important it is for broadband, for mobile broadband. Jessica alluded to it a little bit also. But 40% of the U.S. population lives within like 100 miles of the two coasts. The rest of it's that flyover zone that we talked about. But all your food and energy and water probably come from rural America. So I made a speech a few months ago which said even Donald Trump needs rural broadband. So just keep all that in mind. Why does John Deere care about rural broadband? Well, it's because our machines are now making cell phone calls. We've been installing cell phone modems in our construction equipment since 2006 and our ag equipment since 2011. So that gives you a little bit of an idea as to what type of equipment we're talking about, all forms of construction and lots of ag stuff. So they make cell phone calls. Now, it's not Miss Combine calling up Mr. Tractor for a date on Saturday night. It's data. It's telematic data. It's about how long my machine's been on, how long it's been idling, how much fuel I've consumed, things like that. It's a real eye-opener for farmers when they find out that their machines may be on and idling 30% of the time. That's a big number, and nothing good happens when these machines sit idling. It's a waste of fuel, it's additional air pollution, and it's depreciation on a big machine that depreciates at over $50 an hour. So nothing good happens when these machines idle. But by making these data calls once an hour or a minimum once a day back through the internet, through a cell phone tower back to my John Deere, the farmer can then log in and find out this information about his fleet that he had no way of knowing before. And we find out the more they use it, the more they like it. Now, the next few slides, we're going to talk a little bit about machine-to-machine communications or the Internet of Things. As we talked about already, we're now making phone calls from our machines. It's not just the machines, though, it's other things. Okay, sensors, for example. We're getting big into water management. So we have sensors that we go out and sink into the ground to measure water moisture at depths. We're finding out that farmers tend to overwater. Why? Well, they look at the topsoil and think that it's dry, so they add water even though there's plenty of water below the surface. But if we can provide that data to them, then they make the correct decisions. So this is just a small summary of some types of M2M communications that we're seeing. Grain bin monitoring, roaming restrictions. We can set up basically what we call a geofence using GPS. We can define an area for your machine that it should be working in. If somebody scounds with it in the middle of the night and crosses that line, you get emails saying your machine's missing, and you can hopefully go and call the police and go and find it, and that has actually happened more than once. All right, this is kind of an important map or a graph here for us. This is from Ericsson, and if you look at the horizontal yellow bars, that was the data, or that was the voice requirement for cell phone networks for voice. The exponentially growing red bars are the data requirements on cell phone networks after the introduction of the smartphone, of the iPhone in particular. So we're expecting the exact same thing to happen in the ag space. For example, we've just transitioned from a 2G modem on our machines to a 3G modem this year. LTE and 4G is coming next. We're transitioning from basically a dumb type of phone applications, the one I just described to you, the telematics data, how often your machine's going. That's kind of a dumb phone application that doesn't take a whole lot of bandwidth. It's like 1 kilobit per second. But in the future, we're talking about an exponentially ramp up in smartphone application type applications for the ag space. So the same thing you saw happen with your own phones is happening with our machines. So now, I'm going to show you my maps. Okay, so we started putting cell phones, modems on construction equipment in 2006. So if you have really good eyesight, you can see some dots here around Appalachia, North Carolina, and a few spots out there. So right now, this is just construction machines. A couple years later, sell a few more machines, see a few more dots. You can also start seeing places where you have straight lines forming, probably road construction or repaving, or possibly work along a waterway, maybe locks being replaced, who knows. There's also activity all around the country. So if we extend this again to 2010, again, this is construction only, but we're basically starting to cover the entire country. And there's a whole lot of activity up there in North Dakota. I'm not quite sure what that's about, but maybe you folks know. Okay, so this is 2011, we added the ag side. Okay, our ag division is quite a bit bigger than our construction side, so that made a huge difference in the number of dots you see across the country. 2012 is the last year that we have full data for, so now we're basically covering the entire country trying to make cell phone calls from agricultural areas. Now, if we project these trends forward to 2018, this is what we see. So we're seeing kind of a problem here. Let me give you a little different perspective with a map. This is a little different showing here. Now, I'm not from the Midwest, so it took me a little while to figure out exactly where we are here. But we're basically looking at Iowa in the center. That's the Missouri River on one side and the Mississippi on the other, and the surrounding states. So my color scheme is that the green dots are where a machine tried to call in success and was successful. The white dots are where we tried to call in and were unsuccessful. Now, we logged that attempt, so we know that we tried, and we can produce these maps. So our own empirical data is telling us that we have about a 70% chance of making that cell phone call now. But our fear is that if nothing changes, if nothing is done, then that percentage is going to drop very rapidly to about 50% within a couple years. So it is a big issue for us. We do need mobile broadband, as some of our other speakers have mentioned. So what does this all get us? Why do we do this? Well, it's about several things. When we look at operational efficiency, I would kind of define that as how well a single machine is doing its job. If we talk about increased productivity, now I'm talking about extending that productivity across an entire fleet. Now I'm talking about multiple machines. They're going to be networked together in the future. They're going to be talking to the sensors that I mentioned with the water sensors, maybe other sensors around the farm. This is all something that we call farm sight at John Deere. It also involves environmental stewardship. One of the big ideas behind precision farming, which we haven't had a whole lot of time to talk about today, but that involves the ability to minimize inputs, both seeds, fertilizer, insecticides, pesticides, as well as increasing yields. So those are very good musical words if you're a farmer, right? Decrease cost, increase yields. So that's what all this is about. That's what the future looks like for agriculture. Now, I'm here today from John Deere, but I'm not alone. This is not just our problem. Starting in May, we started meeting with some other folks that have similar issues. So we're calling ourselves the Rural Broadband Working Group, and this is our current membership. A few more will hopefully join soon, but you can see it's a fairly impressive list of agriculture interests. So we've been meeting. We're working on advocacy points to talk to the FCC about things involving the Universal Service Fund, and we can talk a little bit more about that here. So what's our strategy? How do we plan on solving this issue? Well, one of the things I think one of our other speakers talked about was demand. I'm not sure that everyone realizes what kind of demand there may be growing in rural America. Maybe because of us, maybe because of other companies doing the same type things. So we need to document that. There's been very successful examples out in California, I know for sure, about something called demand aggregation. If you're a cell phone company, pick one, AT&T, Verizon, you can't possibly know everything that's going on across the entire country in every state, every city, every county. But if people get together and document what that demand may be in those areas, then they can start making more intelligent decisions. I know, for example, that AT&T has just now started to think about what does this M2M additional traffic mean for our own traffic projections and build-outs. Now, I'm not going to argue that machine-to-machine is going to, in and of itself, create enough demand for a new cell tower somewhere, but it may make what's now a marginal area economic. Another idea is, I think that Jessica mentioned, is private partnerships. Now, I probably should have extended that bullet a little more. It's really private partnerships with the idea to co-locate on the same tower. There are other people, I believe, who need cell towers on what I would say is a more geographical-oriented basis as opposed to population density like the cell phone carriers do. So people like public safety, that would include FirstNet, for example, at a federal level, but also state and local law enforcement. They have the need to cover a geographical area and not just the urban centers. There's other industries that have that similar need. We are seeing a lot of work in transportation these days with smart cars. They have to have a whole lot of communications capability, not just in cities, but everywhere they go. The trains are now going to be required to have positive train control. Trains run a whole lot of places that are rural too. So there may be opportunities where if those folks can all get together and decide, hey, well, we need a cell tower here, now maybe it becomes economical because you've got 4 people using it instead of just 1. So that's another example of things that we're doing in the future. We're also working with PCIA, Personal Communications Infrastructure Association. The head of that organization is Jonathan Adelstein. I'm sure that name maybe rings a bell with some of you. At one time, he was at the RUS with the USDA, and he was an FCC commissioner before that. So I thought he was a very good advocate for us, and they focus on the terrestrial tower side of things because that's our problem. It's a lack of towers. It's not a lack of spectrum. It's not a lack of technology. It's simply there aren't enough cell towers out in areas where our machines work. So one of the ideas that we had, I think somebody mentioned that there's 23 definitions of rural. And that gets very confusing very fast. Maybe we can make it very simple. So that would be my takeaway statement for you. If you don't remember anything else that I tell you today, remember this last statement here. If we work the land, it needs to have broadband. So if it's forestry, agriculture, mining, construction, we need to have broadband for our machines to do our job, for our people to do our job so that we can maintain competitiveness and maintain that $140 billion agricultural export. Thank you very much.